Good afternoon, this is Schweitzer, and this is a video answer sheet for our flip chapter on balancing. So this is not necessarily a instructional video on balancing, but if you're starting this worksheet and you want to check a couple answers to get started, then here we go. Alright, so first things first, when I balance this thing, the way I teach people to balance it is to do an inventory down here of all the atoms present. So in this case, a couple things I'll mention to you. One is that we have polyatomic ions or families. I call them families a lot. For example, this right here is sulfate. So, and again, the way I show this and the way kids do it could be different. I show a long way. Some kids like the long way. Other kids jump right to it. So I'm going to do a couple of examples, and I'll show you. So first of all, if I have a family or a polyatomic ion, I keep it together. Now here, this is ammonium, but ammonium's not over here, so I can't track ammoniums across this thing. So my elements or my atoms that are here are nitrogen, I have hydrogen, I have carbon, and I have oxygen. Alright, so my first step would be to do an inventory. This is a long step, but some kids like it, some kids just move along. But 2 times 1 is 2. Then I have 2 times 4 is 8. I have 1 carbon, and I have 3 oxygens. Over here I have 1 nitrogen. I have 3 hydrogens right here, but I have 2 more over there, so that's 5. And I have 1 carbon, and then I have 3 oxygens. Alright, so that's my inventory. Got to be careful on that, but that's what I got. Now you just gotta pick something. Pick something that's not equal. Typically, if something is all by itself, like an oxygen here, we might wait till that's the last to fill it in. But either way, so let's say I got 2 nitrogens here, so let's just pick a nitrogen. Put a 2 here. Alright, that changes that to a 2. All I can do is increment coefficients. That's a coefficient right there. I cannot change the subscript. That changes the actual identity of the substance. But putting a 2 here creates a 6 here, and then 2 more is 7, 8. So that bumps that right to an 8. Alright, 2 times 3 is 6, plus 2 more is 8. Alright, so that fixes that. Let's see, we got oxygens here. Now I did fix the oxygens here. Now if I fix an oxygen here, I have 3 oxygens here, and I have 3. Oh, it's balanced. Okay, I look at this thing using the inventory method. You'll see it. Actually, it is in fact balanced. I got everything is done. All right, next one. Here I have sulfate here. I have sulfate here. I have thiocyanate here, thiocyanate here. So because they are staying intact, I'm going to actually keep them in my inventory intact. So I have iron, I have sulfate, I have potassium, and I have SCN, which is thiocyanate. That's a -1. Alright, you go +1 if you want, and +3 if you'd like. But either way, so in this situation, we have 2. Now sometimes when I do this, I do my inventory on the fly. So I have 2 irons, and I have 1 iron. Okay, I have 3 sulfates, and I have 1 sulfate. Alright, I have 1 potassium, I have 3 potassiums. So you don't have to wait to do this. You could just do the inventory on the fly if you'd like. 6 here, and looks like we have 1 over here. Alright, so in this case, and again, this is one that's going to get a little bit more complicated. Not just a few bigger numbers, but anyways, I have 2 irons here. So let's just go ahead and fix the irons. Sometimes I like to fix a family first, but it really doesn't matter. So if I fix the iron, I need to put a 2 right here. If you get in a situation where you're stuck, start over. Alright, so that's 2 irons. That bumps this to a 2. 2 times 3 is 6, so it bumps this to a 6. Alright, it also bumps this to a 12. 2 times 6 is 12. Alright, 2 times 3 is 6. So in this case, I got to bump, well, when I pump this to a 6, alright, to a 2, it bumps the potassium to a 6. Potassium's located right here, so I got to put a 6 in front of this guy. Alright, bumps that to a 6. 6 thiocyanates puts this at 6 right here. Alright, now in this case, having 2 irons here, having 2 times 6 is 12, now that's not working out too well. I need to have a 12 right here, or I'm never going to have enough of the potassiums. Now, you'll note here I got 2 times 3 is 6, plus, in this case, I have more here. So I'm going to back that up. This is an example where you have to play around with it a little bit. Alright, and let's get rid of something here. I could probably find an eraser here. Not there. Alright, let's just do this once. Alright, let's change this here. Alright, I'm going to change that to a 12. Because I know that I'm going to need 2 irons here. That's going to give me 2 irons. That's going to fix the iron. That's done. But I get 12 SCNs. I'm going to change this to a 12. There we go. That bumps that to a 12. Alright. And then now I have 12 potassiums. But I got 2 times 3 is 6. I need 6 more here. So that in that situation, I got to put a 3 right here. 2 times 3 is 6. 2 times 3 is 6. Now my potassiums are good. So my potassiums are good, my iron's good, and my thiocyanate's good. Now I have 3 times sulfate here. That's going to be 3, and I have 3 right there. So I've abandoned a little bit of my inventory, but you could keep going with it. You'd see it works just fine. Okay, this would be a 3 right there. Okay. All right, let's take a moment. Let's do another one here. Okay. Copper plus oxygen yields copper oxide. Again, copper is 1, oxygen, there's 2 of them. Now, I didn't put the O2 there, just oxygen. And there's, of course, 2 here, and there's 1 here. 2 elements here only. Alright, so I have 2 oxygens, so pick one. Alright, let's just pick the copper first, I guess. Put a 2 here. Alright, 2 coppers, 2 coppers. 2 oxygens, and we'll put a 2 here. Alright, now that fixed the oxygen, but it ruined my copper. That now gets bumped to 4. Okay, chase it back and forth. Now, some people kind of worry about balancing. And I don't worry about balancing that much. I mean, it's not a critical skill. I would say that also, the more you know about balancing, the more you know about chemistry, the balancing makes sense. Okay. For example, this one, okay, is a solubility reaction. Again, we're learning about solubility reaction. This reaction looks very mysterious, but if you knew what was going on under the hood or at a molecular level, this would make absolute sense. Okay. All right, so how do I go about balancing this one? Again, I would balance without doing the inventory. You can go ahead and pause the video, try it. But I would do nitrate, nitrate. There's 2 nitrates here. Okay, let's put a 2 here. 2 nitrates. 2 silvers, 2 silvers. 2 chlorides, 2 chlorides. Done. Chase back and forth until everything's done. All right, I got magnesium, 4 phosphoruses. Unusual, it's called an allotrope of phosphorus. Magnesium, all right, I got 3, phosphorus 2. So just pick one. 4 phosphoruses, I want 4 over here. Put a 2 here. And 2 times 3 is 6. So I need a 6 right there. Again, feel free to, to balance a few things up as you go. All right. Now, sulfuric acid is one where you may need to review the video on acids here. It is going to be H2SO4 plus NaOH. Okay, and yields H2O plus NaSO4. This is a +1, this is a -2, so the 2 goes here, the 1 goes right here. You'll notice I did that right here as well. +1 -2. +1 -1. And that's water. Alright, so balancing again. Pick a family. I got 1 sulfate here, I got 1 sulfate here. Sometimes I like to balance families first. I'm not sure why. 2 sodiums. Okay, let's put a 2 right here. 2 oxygens. Now I don't count these oxygens because they're already counted in the family. 2 oxygens, right? And therefore I need 2 here. Gives me 2 oxygens. 4 hydrogens, and you'll find that I have 2 hydrogens here and 2 hydrogens, which is 4. Alright, hydrogen gas plus oxygen gas yields water. Alright, now I put the 2's on here because these are diatomic atoms. There are 7 that are super common diatomic atoms, and they are N2, O2, F2, Cl2, Br2, O2, and H2. If you see them by themselves, for example, O2 is that, but H2O does not have a 2 right there. If you did that, that'd be H2O2. That's hydrogen peroxide. This one's essential for life. This one will kill you. Okay? Alright. So, balancing first. 2 goes here. That gives me 2 oxygens and 4 hydrogens. So then we put a 2 here. The rest of these you can check for answers online. Number 8. All right, let's do this burning one first. Ethylene. All right. So we have just to show a combustion reaction. I have C2H2 plus O2 yields carbon dioxide and water. Now, combustion reactions really, any science teacher who teaches chemistry can throw you a chemical reaction that will be an absolute bear to balance. But in reality, 99% of the reactions that we do balance very easily. So if you're having problems with balancing, don't worry about it. Most of them are easy. Sometimes the hard ones are actually combustion reactions. But you'll see, if you balance it in carbon, hydrogen, and oxygen in that order, this thing will balance always very easily. Now, if you put a 2 out front here, it will balance every single time. But it may not be reduced to its lowest common multiple. So that being said, or lowest common denominator. But either way, so carbon first, 2 carbons, you put a 2 here. And these are the hard ones, okay? Hydrogen's next. 2 hydrogens, 2 hydrogens, okay. 4, now I want to put a number right here to balance that oxygen, if I can. I have 2 times 2 is 4, plus 1 more is 5. So I can't get 5 here, no matter what. I got a 2.5. And that would be actually absolutely legitimate if you'd like. But in this case, the 1 didn't work. So I'm going to put a 2 here. And like I said, 2 always works. So everything doubles. 2 times 2 is 4, so I need a 4 here. 2 times 2 is 4, so I need a 2 right here. Notice those numbers just doubled. 2 to 4, 1 to 2. And now the number I needed actually doubles. So 2 times 4 is 8, plus 2 more is 10. I had needed 5 before, but now I need 10. So a 5 goes here to get me to 10. Okay. And finally, the last little thing I'm going to give you here is a little bit of thought on this next page. All right, there are some errors on this page, and one of the reasons why the number one reason why something won't balance is because there's an error in the problem. And if it's an error in it, it will never balance. It may not balance. It surely won't balance correctly. Okay. So what we want to do here is we want to look for the error, and then we can balance it. I might just show one of these maybe here. Okay. Now the most common error that kids make